In the second segment of miscellaneous inverse trigonometry, let's start the question number 7. Tan inverse 63 upon 16 is equal to sin inverse 5 by 13 plus cos inverse 3 by 5. Proceeding from right hand side, we can write down sin inverse 5 by 13 as tan inverse 5 by 12 and the other one as tan inverse 4 upon 3. Now we can easily apply the identity tan inverse x plus tan inverse y. Tan inverse x plus y upon 1 minus xy. Gives us 15 plus 48 divided by 36 minus 20 is equal to tan inverse 63 upon 16. As I have already specified, this identity tan inverse x plus y upon 1 minus xy in place of tan inverse x plus tan inverse y is applicable when both are positive, which is the case, and second is xy is less than 1. That again is applicable here as 5 by 12 into 4 by 3 is less than 1. Next question. Question number 8. The question is tan inverse 1 upon 5 plus tan inverse 1 upon 7 plus tan inverse 1 upon 3 plus tan inverse 1 upon 8. This whole equal to 5 upon 4. So we'll apply tan inverse x plus tan inverse y identity twice. First, apply it for tan inverse 1 upon 5 plus tan inverse 1 upon 7. This becomes 1 upon 5 plus 1 upon 7 whole divided by 1 minus 1 upon 5 into 1 upon 7. The next two, when we are applying the identity, becomes 1 by 3 plus 1 by 8 upon 1 minus 3 into 1 by 8. That is giving us 12 upon 35 minus 1, 34 plus 11 upon 24 minus 1, 33. We need to apply identity once again, which gives us 12 upon 34 plus 11 upon 23 whole divided by 1 minus 12 upon 34 into 11 upon 23. Now 12 into 23, 12 into 3 36, 12 into 2 24, 24 and 3 27 plus 11 into 4 44, 11 into 3 33 and 4 37 divided by 23 into 4 92, 9, 23 into 3 69, 69 and 9 78 minus 12 into 11, 11 into 2 22, 11 into 1 11 and 2 32 13. This equals 6 and 4 10, 7 7 14 and 1 15, 2 3 5 and 1 6, 2 minus 2 0, 8 3 minus 8 minus 3 5. So that is tan inverse 1, which gives us 5 upon whole square. Tan inverse root x is equal to half cos inverse 1 minus x upon 1 plus x. it's given that x is lying between 0 and 1. So proceeding from left hand side, we'll make this adjustment, multiply and divide by 2. And then this identity 2 tan inverse x is written as cos inverse 1 minus x square upon 1 plus x square, which on further simplification gives you 1 minus x upon 1 plus x. This identity is valid when x is lying between 0 and 1, which is the case. Therefore, this result is okay. It's good. Question number 11. Cot inverse under root 1 plus sin x plus under root 1 minus sin x whole divided by under root 1 plus sin x minus under root 1 minus sin x equals half. And domain for the question is x belongs to 0 to pi by 4. One plus sin x can be written as cos x by 2 plus sin x by 2 whole square. 1 plus sin x is equal to cos square x by 2 plus sin square x by 2 plus 2 times cos x by 2 sin x by 2. 1 is replaced by cos square x by 2 and sin square x by 2 and sin x. 2 sin x by 2 cos x by 2, which makes it cos x by 2 plus sin x by 2 whole square. Now when we put this thing in this root, because of perfect square it comes out of the root sign. Other one is cos x by 2 minus sin x by 2, because it is 1 minus sin x. In the denominator we have cos x by 2 plus sin x by 2. After minus, the sign will change. Therefore cos x by 2 minus sin x by 2 will become minus cos x by 2 plus sin x by 2. On simplification, we are getting cot inverse cot x by 2. Now, this will be equal to x by 2 if it is lying in its range. Now check it. X is given lying between 0 and pi by 4. Therefore, x by 2 will lie between 0 and pi by 8. So it is well within its range, as its range is between 0 and pi. Range of this function is between 0 and pi. X by 2. Henceforth. Tan inverse under root 1 plus x minus 1 minus x whole divided by 1 plus x plus 1 minus x. This whole equal to pi by 4 minus half cos inverse x. And it is given that x is lying between minus 1 by root 2 and 1. As we know, we have identity for 1 plus cos theta as well as 1 minus cos theta. So x is equal to cos theta, and that will give us tan inverse 1 plus cos theta 1 minus cos theta whole divided by 1 plus cos theta plus 1 minus cos theta. 1 plus cos theta using a special result of half angle is 2 cos square theta by 2. So when taken out of root sign, it becomes root 2 cos theta by 2. 1 minus cos theta 2 sin square theta by 2 gives you root 2 sin theta by 2. Same thing when done in the denominator, root 2 cos theta by 2 plus root 2 sin theta by 2. This on simplification gives us cos theta by 2 minus sin theta by 2 divided by cos theta by 2 plus sin theta by 2. When we divide numerator and denominator by cos theta by 2, we get tan inverse 1 plus tan theta by 2 1 minus tan theta by 2 divided by 1 plus tan theta by 2, which is tan pi by 4 minus theta by 2, using that famous identity of tan p minus b. For tan pi by 4 minus theta by 2, you can say it is tan pi by 4 minus tan theta by 2 divided by 1 plus tan pi by 4 into tan theta by 2. Tan pi by 4 is 1, so that makes it 1 minus tan theta by 2 divided by 1 plus tan theta by 2. Now once again we have to check for its range. Tan and tan inverse gets cancelled, only 1, pi by 4 minus theta by 2 lying the range. We have assumed x is equal to cos theta, and x is lying between minus 1 by root 2 and 1. Therefore our cos theta will lie between minus 1 by root 2 and 1. Implies cos inverse minus 1 by root 2 is less than equal to theta, which is less than equal to cos inverse 1. Implies cos inverse minus 1 by root 2 will be pi minus pi by 4, and cos inverse 1 0 degree. So theta is lying between 3 pi by 4 and 0. Now we have to check for pi by 4 minus theta by 2. Divide by 2 and multiply with minus 1. Direction of inequality will change 0, and this one becomes minus 3 pi upon 8. Now adding pi by 4 to all, we get this one as greater than pi by 4 and less than pi by 4 minus 3 pi by 8. When we simplify, this one is minus pi by 8. When we apply logic, it is auto corrected to pi by 4 minus theta by 2 is less than minus pi by 8 and greater than pi by 4, which is well within its range. The range of this function is between minus pi by 2 and pi by 2. So this one is giving us pi by 4 minus theta by 2, and according to our assumption it becomes half cos inverse x, because x is equal to cos theta. That makes it cos inverse x is equal to theta. So theta is replaced by cos inverse x instead. Next question is very simple. It is prove that 9 pi by 8 minus pi by 4, 9 by 4, sine inverse 1 by 3 is equal to 9 upon 4 sine inverse 2 root 2 upon 3. Proceeding from left hand side, take 9 by 4 common, because that will give you pi by 2 minus sine inverse 1 by 3. Now this becomes cos inverse 1 by 3 as sine inverse 1 by 3 plus cos inverse 1 by 3 is equal to pi by 2. Now to express this one in the form of sine inverse, this is base upon hypotenuse, we need perpendicular, and base is 1, hypotenuse is 3. Applying Pythagoras, it becomes 2 root 2. So this way you obtain the right answer. Next one. Question number 14. It's about solving. Whenever the question is about solving, we have to find the variable. 2 tan inverse cos x is equal to tan inverse 2 cosec x. So since it is about solving, it means we have to find the value of x. To solve this, we'll apply the identity for 2 tan inverse x in the form of tan inverse, which is tan inverse 2x upon 1 minus x square. Right side can be written as 2 upon sin x. On comparing, we can say this is equal to 2 cos x upon sin square x is equal to 2 upon sin x. When we simplify, we are getting tan x is equal to 1, which gives us x is equal to pi by 4. Hence it is good. Next one is the value. Tan inverse 1 minus x upon 1 plus x is equal to half tan inverse x. Again this thing is given, x is greater than given, as it is valid for this condition only. So once again, proceeding with 2 tan inverse 1, which gives us tan inverse 2x, 2 into 1 minus x upon 1 plus x divided by 1 minus x square. That makes it 1 minus x upon 1 plus x whole square is equal to tan inverse x. On simplification, we are getting 2 into 1 minus x upon 1 plus x into 1 plus x whole square divided by 1 plus x square plus 2x minus 1 minus x square plus 2x is equal to x. When simplified, x square gets cancelled, 1 and 1 gets cancelled. 1 plus x also cancelled. So we are getting 2 into 1 minus x square is equal to 4x square, which can be written as 2 minus 2x square is equal to 4x square, implies x square is equal to 1 by 3. Therefore, x is equal to plus minus 1 by root 3. Now since x has to be greater than 0, therefore x is equal to 1 by root 3 is the right answer. Minus 2 sin inverse x is equal to pi by 2. And we have to again find the value of x. Take sin inverse x is equal to something. Say I am taking sin inverse x is equal to t. So that will give us x is equal to sin t. Apply it everywhere. Sin inverse 1 minus sin t minus 2t is equal to pi by 2. In the next step, we get sin inverse 1 minus sin t is equal to pi by 2 plus 2t. In the very next step, we have 1 minus sin t is equal to sin 90 plus theta. Sin 90 plus theta gives you cos theta. Second quadrant. In second quadrant, sin is positive. And because of complementary nature, sin changes to cos. Cos to theta can be written as 1 minus 2 sin square theta. Now 1 and 1 gets cancelled, and when we simplify it, we are getting 2 sin square t minus sin t equal to 0, which gives us two values of sin. One is 1 by 2, another one is 0. This is how it is. Take sin t common. We are having 2 sin t minus 1 to 0. Now we have to check for these two values which one is correct and which one not. Sin t is equal to half means x is equal to half. When we put x is equal to half, we get sin inverse 1 minus half minus 2 sin inverse half in the left hand side. And we want this one to be equal to pi by 2. This one is sin inverse half. Sin inverse half is positive angle, that is pi by 6. Or we can simply write down sin inverse half minus 2 sin inverse half as 1 minus 2 gives you minus 1. So we can easily see this is equal to minus pi by 6, not equal to pi by 2. So x is equal to half is not a true solution. Now check for x is equal to 0. We have sin inverse 1 minus 2 sin inverse 0 equals pi by 2. Sin inverse 1 is pi by 2. So pi by 2 is equal to pi by 2. Therefore x is equal to 0 is the right solution. Now the last question of this. Question number 17. Tan inverse x upon y minus tan inverse x minus y upon x plus y. We have to simplify it. For the easier approach, in the next expression we will divide numerator and denominator by y. So this is what we are getting. Tan inverse x upon y minus tan inverse x upon y minus 1 upon x upon y plus 1. This can be written as tan inverse this one is playing the role of x, this one is playing the role of y. Say this one is a, other one is b upon 1 plus a into b. So we can say this one will be equal to tan inverse x upon y minus tan inverse 1 inside the bracket. When you open it, you will get tan inverse 1 because these two gets cancelled and that is equal to 5. That is the right solution. So hopefully you would have understood all the questions explained by me in the study.